Our third lesson from 7.4, we're dealing with simplifying radicals. It's actually going to be multiplying the expressions that have radicals in them. And you're going to be using a lot of the skills you've used when you didn't have a radical expression. So for example, if you look at the two expressions I've written here, 3 times x plus 4 and x plus 2 times x minus 5. In these examples, when you have done this before, you distributed the 3 with 3 times x and 3 times 4. And like on this one, you went x times x and x times minus 5, and then 2 times x, and then 2 times minus 5. You're going to be using those same ideas of distribution as you work with simplifying radicals. So let's get started with those. So here's a radical expression. At the square root of 2 times 6 plus the square root of 10. So what we do, we're going to take the square root of 2 times 6. So I'm going to go like this. And I'm going to say that is 6 times the square root of 2. Now I will take the square root of 2 times the square root of 10, and I'll use the product rule, and I'm going to do the 2 times the 10 on the inside. So this is plus the square root of 20. At this point, we might think, gee, I'm done. Not quite. We have to then look and see, are there any perfect square factors since I'm dealing with square roots? Is there any perfect square factors in the square root of 2? Nope. Are there any perfect square factors inside 20? Yes, there is. There is a perfect square factor of 4 in there. So I need to simplify that out. I need to bring that out, that rational number out. And that square root of 20, as we take a look at it, then breaks into square root of 20 is the same as the square root of 4 times the square root of 5. So the square root of 4 then is the same as 2. So the square root of 20 changes to 2 times the square root of 5. So to show you how you do this on your paper over here, what I would do if I was writing on the paper, I'm going to copy the 6 times the square root of 2 plus this I will change into the square root of 4 times the square root of 5, and that I then write 6 times the square root of 2 plus 2 times the square root of 5. And I stop here. And I won't go any further, and the reason is I cannot add these together. These are not like terms because the first term has the square root of 2. Second term is the square root of 5. Those aren't like terms. Each of those represents different numbers. So I cannot add the 6 and the 2. I have to leave this expression as it is now. That's example 1. Example 2. Here we go. We have a binomial times a binomial. Square root of 3 minus square root of 5 times the square root of 2 plus 7. All right, so let's do the square root of 3 times the square root of 2 is the square root of 6. Square root of 3 times 7 is plus 7 times the square root of 3. Then I have a negative times the square root of 5 times the square root of 2. So that's a minus square root of 10. And then I have the negative square root of 5 times 7. So then it's minus 7 times the square root of 5. At this point, I'm looking to see, do I have any like terms? I have a square root of 6, and I'm also looking for perfect square factors. So square root of 6, square root of 3, square root of 10, square root of 5. There are no like terms there. Are there any perfect square factors that I need to simply take out and factor out? 6, 3, 10, and 5, none of those are perfect squares, so at this point I'm done. This is all I can do with this one. I can multiply, do the distribution. Because there are no like terms, this is the answer that I have. This is the thing about radical numbers. Since they're irrational, a lot of times we sometimes end up with extra terms that are more than what we're used to seeing. But that is how it works. All right, one more example that I'd like to show you is here I have binomial times a binomial. Now this one has a pattern. I wonder if you can recognize this pattern. I have the square root of 5y plus 2, and notice I have the square root of 5y minus 2. This is the product of a sum and a difference. Okay, product of a sum and a difference. There will be a few problems like that that I'm going to ask you to do. There's either the product of a sum and a difference, or maybe it's the square of a sum of binomials, or the square of a minus in a binomial. And I'll show you that in a second. But here, the product of a sum and a difference. All right, I'll write this out the long way. The square root of 5y times the square root of 5y. Well, the square root times a square root equals the number on the inside. So that will be 5y. Now I have the square root of 5y times a minus 2 times the square root of 5y. And I'm writing it this way just in case you don't recognize or realize that the pattern that's possible here. And now I have 2 times the square root of 5y, so it's plus 2 times the square root of 5y. And as you're watching, can you predict what's going to happen to those last 2 terms? If you remember that pattern, you will know. If you don't, maybe this would be a nice review for you. So 2 times the negative 2, that's a minus 4. Take a look here. Now let's do, we have like terms to combine. 5y, there's no other terms with the plain y. Now I have a minus 2 times the square root of 5y plus 2 times the square root of 5y. And as you know, those cancel out because they are opposite. And then I have a minus 4. So the final answer here is 5y minus 4. And now take a look again at that pattern. Is that the pattern that we're used to seeing with this product of a sum and a difference? So then if I have a plus b times a minus b, same number minus the second number. Those numbers were the same. So when I hold the pattern holds, a times a is a squared. Then I do a times the minus b gives a minus ab, which we had a minus 2 times the square root of 5 here. Then I have plus b times a positive a, so that's plus ab. And then notice I had a plus 2 times the square root of 5. And then I had b times minus b gives us a minus b squared. Well, 2 times 2 is 4. Positive times a negative is negative. And then again, our middle terms cancel, so we end up with a squared minus b squared. So let's take a look. Did we end up with that? We have square root of 5y times the square root of 5y. There's the answer is 5y. And then 2 times 2 is 4, and I have a minus in between. So it does follow the same pattern, even though there's a radical involved with it. If you recognize the patterns, you could have taken this first line right here that's in black, and you could have gone right down to this line if you recognize the pattern. If you don't, you just follow your distributing, cancel out your middle term when you do your like terms, and you'll still get the same answer. Works either way. Another item you might see might be something like this. You might see something that looks somewhat similar to this, like the square root of 5 plus n, and that is squared. And we have to remember when you see this, that is the square root of 5 plus n times the square root of 5 plus n. And we distribute this way. And if you remember, this one also has a pattern to it. That our pattern, if I'm using, I'll write this out the long way. So I do the square root of 5 times the square root of 5 is 5. Square root of 5 times n, that's going to give me plus n times the square root of 5. And then n times the square root of 5 again gives me another plus n times the square root of 5. And then n times n gives me n squared. Looking for like terms, I have n plus the square root of 5, I have it twice. So I start by saying 5 plus 2 of those n times the square root of 5 plus n squared. So how can I use my pattern from up over here? What was that pattern? Well, the pattern is the first term is squared. Square root of 5 times square root of 5 is 5. Then I have the 2 terms multiplied, n times the square root of 5, and then I double it. So plus 2n times the square root of 5, because I double. And then I had left the last term squared, which is then n squared. So you can also use this pattern. If you don't recognize the pattern on something like that already, please write it out this way. Use your distributing, and you will still get the same answer. Might have an extra step, but that's okay. So here's what I want you to work on. From page 441, I would like for you to do problems 47 through 59 odd, and then 63 and 65. And the reason I'm giving you all odd numbers again is so you can check your answers. So be sure that you, after you do that, again, always check your answers in the book and then turn it in. All right, go ahead and get started on that. Flag me down if you need me for some help.